Hello, Joe. Welcome to the ReGen X generator and ReGen X quantum motor demonstration. And this video is going to be talking about the ReGen X stepper motor circuit that we need you to design for us. A stepper motor circuit that is capable of 10 to 100 amps of input current from the battery. So basically what we have in our prototype is a ReGen X generator coil, which is mounted on a met glass core. And as you're going to see in the video, even though this is met glass and the hysteresis curve is symmetrical and the cogging torque in the core is supposed to be 0. The core still presents hysteresis drag on the prime mover. And what we want to be able to do is to use the ReGen X generator coils as ReGen X stepper motor coils, such that they work in concert with the prime mover. And so we essentially have two motors working in tandem. And eventually, so this application is for all existing EVs that are on the road today, where we integrate the regenerative acceleration technology into the existing drive shaft or EV propulsion system. So Tesla, which uses an induction motor, can have the technology integrated into it on the same drive shaft, and it will provide regenerative acceleration and regenerative acceleration in motor operation, regenerative acceleration in coasting operation, regenerative acceleration on deceleration, and regenerative braking during deceleration. So what I'm going to show you in this demonstration is the ReGen X generator coils that will be charging the battery when the switches are on this side, and accelerating the system in regenerative acceleration mode. And then just connecting the battery here. And then when we go into quantum motor mode is, or I should say regenerative acceleration mode is infinite efficiency generator operation. And then we go into quantum motor mode with the switches on this side, which is infinite efficiency electric motor operation. And so what we need at this point, and we're monitoring the voltage. You'll see the voltage go up, and you'll see the current going from the coils to the battery increase every time we switch on a coil. And you'll see the power consumption to the prime mover go down. So the more power we send to the EV's battery in regenerative acceleration mode. The less power is required by the prime mover. So again, in an EV, when we're in regenerative acceleration mode, the EV's existing motor consumption will go down, while the more power that we send to the EV's batteries in regenerative acceleration mode, the faster the battery will recharge, and the more the EV will be accelerated, and the more the consumption of the EV's drive motor will go down. So eventually, we're doing two things. We're creating a retrofit for all existing EVs, and then what we want to do is eliminate, for new EVs, we'll eliminate the existing Tesla or Faraday propulsion system, and we'll just use the ReGen stepper motor system to propel the EV. And then the CPU that you're going to develop as well will dictate road conditions, driver input, battery recharge state, and so on. And it will decide which coils are in quantum motor mode, regenerative acceleration mode, regenerative braking mode, or basically just turned off. So that's what the CPU will do. It will decide what is the optimal optimal mode for each salient pole coil. This prototype is designed for 12 coils. For ease of demonstration and operation, it has 3 coils, and so there you have it. So what I'm going to do, I'm going to fire up the system. We're going to look at the RPM of the system. We'll look at the various RPMs and all the other parameters in regenerative acceleration mode, and we'll look at the parameters in quantum motor mode, and then I'll reduce the system speed down to about 2,000 RPM or thereabouts, essentially below the critical minimum operating frequency for the coil. When the ReGen coils are operated below the critical minimum frequency of operation, they operate as normal Faraday generator coils, and they produce regenerative braking, generator armature reaction, a counter electromagnetic torque, and so on. Okay, so this number here is the power that's going to the prime mover. Now what I also want to look at, just for curiosity's sake, I want to look at the I want to look at the current going to the battery in the current going to the battery in generator mode, and the current going to the battery in quantum motor mode. And my assumption is that the current circulating through the coils is going to be higher in quantum motor mode because it's not connected to the battery and you don't have the resistance of the battery to drop the current. So I'm curious to see what that's going to be. So current going to the battery in generator mode, regenerative acceleration generator mode, and regenerative braking mode, and the current going to the battery in quantum motor mode. Okay, let's fire it up, see what happens. So there you have it. Regenerative acceleration in generator mode. Infinite efficiency generator operation with EV acceleration. And regenerative acceleration quantum motor mode. Positive work being performed at infinite efficiency with created electromagnetic field energy. And regenerative braking below the critical minimum frequency. Negative work being performed at infinite efficiency with created electromagnetic field energy. So I'll collect the data, and what I'll also show in the data is the kinetic energy of the system at each operation. So no load, on load, and I will calculate the kinetic energy increase and the kinetic energy decrease. And the kinetic energy of the system is the energy that's obviously stored in the system as kinetic energy. It's in joules. When we increase the speed of the system, the increase in the kinetic energy is equal to the created electromagnetic field energy that is performing positive work and accelerating the system, minus the bearing friction and the air friction on the rotor. In regenerative braking mode, the created electromagnetic field energy is equal to the negative work that's performed plus the bearing friction and air resistance. So I'll do those calculations and I'll put that in the data, but initially this is what we need. We need to be able to operate our ReGen X motor in stepper mode operation, or I should say regenerative acceleration ReGen X stepper motor operation, so that we can allow it to work in tandem with the existing drive system and not acting purely as a hysteresis brake, and then also as a standalone EV motor. Okay? Talk to you later. Thanks, bye.